So I guess, yeah, welcome to session 3, which is on software security. We have 5 papers. The first one, but before we start, we need permission to record your
no problem.
actually. Yeah. So the first paper is a tool dataset paper, building a commit level dataset of real world vulnerabilities by Alexis Challande. And so I leave the floor to him.
Okay. Okay, so thanks everyone for being here today. I'm sorry for my French accent, and so you're gonna have to bear with me for the next 10 minutes. So first to introduce myself, I'm Alexis. I'm working as a PhD student doing my 3rd year, and I'm doing my PhD in Quarkslab, which is a reverse engineering company in Paris, and my academy is École Polytechnique in France. So today we're gonna get interested that the problem is when you're building a new tool or doing some research on trying to find if you have a new solution or new ideas for a problem, you need to test your solutions, and you need to do it efficiently to be able to compare yourself with each other and other academic work. So you have potential solutions to do this. Either you create a data set from a few binaries with known vulnerabilities like OpenSSL, zlib, or whatever. You compile them and so on, and you spend some time doing this. You can also create some synthetic toy project, and then you add encrypted vulnerabilities, and then you try your tool on this data set where you control every variable, or you use something that I'm going to present today. So to summarize what we're going to present, this is a commit level dataset, meaning that it's a dataset of more than 1900 vulnerabilities. It's based on real world issues, so CVEs, and it's precise at a commit level, meaning we exactly know which is a commit that fixes the vulnerability. So the project before is the fixing commit is vulnerable, and afterwards it's fixed. And then because source data is not on necessary all the time, you have also binaries precompiled for 600 of these vulnerabilities in 4 different architectures, and with debug symbols available when they are available. And everything is available on GitHub, so you have the link on the slide. So with the anyone doing work and trying to do which is synthetic, small example, so it's not really workable. You have generated data set mostly for fuzzing, so lava, magma, and so on. And you have CV data set, but nowadays there's small discontinuity and so on. So this kind of data set is used for many applications. We list a few of them on this slide. For example, you could do some patch characterization, meaning like, can you identify if a patch is a security one or not, just by looking at the change made on the source code. You could also try to understand if a fix is a silent fix for a vulnerability that has not been publicized by the authors of a project to hide that they were vulnerable to something. You could also use it for cross-architecture binary diffing, for example, or even application from source to binary and so on. Or you could do it like patch detection, as I mentioned in my previous slides. So now that we understand what this data set is used for, let's try to see how it has been created. So we go back to Android, and the core of Android is the Android open source project. So it's composed about 2,000 projects, and you have about 1,200 tags and so on. 6 architecture, and each version is composed about 250,000 files in C, C++, and so on. So it's kind of huge, and compiling it takes quite a lot of time. But it's also the core of the most used operating system in the world nowadays. So it's kind of interesting. And what is also more interesting is how Android security is made. So as some members of the previous panel said, the update process is tedious in Android, like in every distributed system and IoT devices, because you have multiple stakeholders. So for Android, it's Google, obviously, but also the operate manufacturers, the carriers, and so on. It's complex because then everyone is doing modification at the same place, and even Project Rebel that was trying to create a boundary between the Google own code and the owned by others is not solving everything. But thanks to us, Google publishes monthly security bulletins, which lists a vulnerability that has been fixed in AOSP during the last month. And those bulletins contains a CV ID, severity, and most important, a fix to the commit ID, a link to the fixing commit. So this is an excerpt of the March 2022 bulletins, and you see the links in the reference column that are direct links to the subversioning system. So we created a tool named Void that detects based on the security patch level of a device which are the CV affecting it. And how does Void works? It just crawls the Android security built-in, passes the result, and then store them in a database. So it's something easier to retrieve than just looking at the web pages. And that's allowed us to create this first step of our data set, and that's why it's precise at the commit level. So now that we have this information, we can also go towards binary artifacts, and those binary artifacts are really useful when you are looking at vulnerabilities, for example, that are not only in open source components, but also in closed source solutions. So AOSP is something super cool for building and automating building, because the build system is documented and it's actually working. It's something that works in a cross architecture, so you can have this binary built for a few devices, a few architecture. So to do this magic build, we just process the result from Void. So we have now the fixing commit, and now we build AOSP before and after the commit has been applied, and then we do some build diffing, and we have the fixed binaries on one side and the vulnerable binary on the other side. So let's now understand what is exactly inside the dataset. So at the source level, we have a huge set of vulnerabilities, about 3,400, and more 1,900 of them have commits information. So the difference is because not every component in AOSP is open source, and so every component in AOSP is open source, but the built-ins cover some other components that are closed source. And it's also ever increasing, so that means since we have built-ins every month, then it's always up to date. It's only on its limitation, it's only open source components, and it relies on Google commitment to publish built-ins, obviously. So you have a few figures for how many vulnerabilities there are. So it's quite stable over time, and the column for 2022 is a bit smaller because it's the figures ends in March. And most of vulnerabilities in Android are quite severe because more than 60% of the data set has a CVSS score of more than 7. At the binary level, so I already mentioned that we have about 600 vulnerabilities that are precompiled, and it takes about 100 gigabytes. You have also the links to download everything on GitHub, and it targets 4 different architectures. So because it's a compiled code, we only targeting C and C++. Build automation is super hard. We can talk a bit outside of this talk if you want to understand why. So it has a lot of failure, and then it's only considered vulnerability after Android 6, because Android 6 is already kind of old, and it's hard to create that build environment for this system nowadays. So that's an example of a vulnerability in this binary level dataset. So you have folders for every architecture, and then the files fixed and vulnerable in every subfolder prefixed by the hash to prevent many collisions. So we have a lot of binaries. Most of them are libraries, shared libraries, and some of them are object files. And the most common one is the libbluetooth, because first it's a component that has been quite updated in the last years, and it's super easy to compile. So it works most of the time for it. How to use the dataset? So everything is on GitHub. You have the CV, the repository that is organized as follows, as presented on the slide, and then you have the schemas if you don't want to use Python and so on. And to conclude, so it's 1900 commit precise real world vulnerabilities. So it's not a made up example, it's a real world vulnerabilities that affect real-world project used by billions of people, and you even have something precompiled if you want to do like every kind of different analysis, and that's one for me. I'm a bit early, but I talk a bit faster. The paper is on the repository as well.